Hi guys, welcome back to another video of me solving number theory questions, and today I have this question. So this question says that 34 factorial is equal to that something CD and then that AB and then 6 zeros. And the question is telling us to find A, B, C, and D. Well, I'm going to first tell you a little note, okay? So just write down note. Yeah. Okay. This note is, I'm going to first write down an easier factorial, say 10 factorial. Okay, that's easy. Well, if we did a prime decomposition to this, then if I asked you how many powers of 3 there would be in here, then how do we calculate it? Well, it is pretty obvious at first, because there's a 3 here, the 6 is 2 times 3, so there's 2 3s, and the 9 is 3 squared, so there are 2 3s again, so it's 4. Well, for bigger numbers, it's harder to just do that. So then how do we calculate this x? Well, I'm going to tell you. This is pretty obvious once you understand the concept. So x is equal to the floor of 10 over 3 plus the floor of 10 over 3 squared. Now, some of you guys might be wondering why I had to add this part. Well, it's because for the squares and cubes of 3, or the powers of 3, there are going to be multiple 3s. So, if we just had this, then we would miss one, because this 9 includes 2. Well, we can't keep adding because then that would all be 0. So this is equal to 4, or 3 plus 1, which is equal to 4. Now, this being said, why don't we just, for fun, just prime decompose 10 factorial? Okay, let's first calculate the powers of 2. I'm going to write it here. 2 to the power of, well, it's the floor of 10 over 2 plus the floor of 10 over 2 squared, which is 4, plus the floor of 10 over 2 cubed, which is 8, and that's all. This is equal to, this is a whole number, which is 5, and then plus 2, and then plus 1. So this is equal to 8. Power of 8 multiplied by 3 to the power of the floor. Actually, we already calculated 3. It was 4. Multiplied by 5. Well, we can actually do this in our head. The floor of 10 over 5, which is a whole number, 2, and that's all. 7 to the power of 1, 13, 0, so the rest is gone. So this is our prime decomposition of 10 factorial. And you can verify this on your own. You can ask like ChatGPT or something that this is the prime decomposition. Well, now we will go back to the real question. Okay, well, there is a very interesting part about this number, is that at the end there are 6 zeros. Well, what only two prime numbers can make out a 0? Well, obviously 5 and 2, because they can make up 10. So this implies that we should figure out how many powers of 5 and how many powers of 2 are in 34 factorial. Well, let's go. So how many numbers of 5 are in here? It's the floor of 34 over 5 plus the floor of 34 over 25. So this is equal to, this will just be 6, and this would be 1. So it's 7. Now let's move on to 2. Is equal to the floor of 34 over 2 plus the floor of 34 over 4 plus the floor of 34 over 8 plus the floor of 34 over 16 plus the floor of 34 over 32. And if you calculate this on your own, 32. Well, so this being said, it's actually 5 to the power of 7 times 2 to the power of 32. And I'm not saying that this is the full prime decomposition of that. I'm just saying that this is hidden within 34 factorial. So this is hidden within 34 factorial. Well, how many zeros can we make? Not 32, because there aren't enough 5s. So 7, right? So it's 5 to the power of 7 times 2 to the power of 7 times 2 to the power of 25, which is equal to 10 to the power of 7 times 2 to the power of 25. So there would be 7 zeros at the back of our number. But we only have 6. So that means that the number straight before the first zero has to be 0, which is B. So B has to be 0. Very nice. Okay. Now we have to figure out A. Now let's consider 34 factorial over 10 to the power of 7. Okay? Well, once we divide it out to the 10 to the power of 7, then those zeros are gone, including B. And remember when I said that this number has a 10 to the power of 7 and a 2 to the power of 25 in it? Well, once we divide it off the 10 to the power of 7, then we only have the 2 to the power of 25, right? So this 2 to the power of 25 is still hidden within this number. And 2 to the power of 25 is obviously 2 to the power of 3 times 2 to the power of 22, which is equal to 8 times 2 to the power of 22, right? And if 8 is hidden within this number, then it means that this number has to be divisible by 8, right? And recall the rule of dividing by 8 is that the last 3 digits of our number has to be divisible by 8. And our last 3 digits are, forget the B and all of the zeros, is 35A. So we have to calculate 35A divided by 8, which is 4, 32, 30A. Well, there's only one choice of A, which is 2. So, that being said, A has to equal 2. Now, some of you guys might be wondering why I didn't do 4, but I did 8. Because if we divided by 4, then it would be much simpler, right? So I'm going to write it out for you, because for 4, it's the last 2 digits. So 50A divided by 4, 1, 4, 1A. Well, there could have been many answers, because A can be 2, A can be 6, and that's all. 2 answers. But we don't like 2 answers, we like 1 answer. So that's why I didn't do 4, because 4 is a pretty small number. Now we can go back to this. Well, why don't we try to dig out CD out of this number, okay? And just a warning, this is super fun. Well, CD is 2 digits, right? Well, if it's 2 digits, then why don't we try to dig in groups of 2? So then that would be 10 to the power of 2, right? Because if you recall our last video, we did in groups of 6, and now we can do it in groups of 2. So 10 to the power of 2 is equal to 100. And we like congruent to 1, right? So this is congruent to 1. What's the easiest one? Mod 99. Okay? Now, this means that if we use our little property that I said in the last video, then we will know that this is 10 squared, and that if we copy and paste this to the next line, then it'll be 10 squared again. And we can multiply them together to make it 10 to the power 4 is also congruent to 1. So this means that every even power of 10 is always congruent to 1, mod 99. Oh, and just a little side note, this number has 39 digits. Well, why don't we start off with AB? So it's AB times 10 to the power 6, which is congruent to 10 to the power 6. 6 is an even number, so this is congruent to 1. Look at the bar. Well, so this is congruent to AB. And if you don't know what this bar means, it means that AB is not multiplication. It is a number. And of course, don't forget the mod 99. Now let's go to 35. 35 times 10 to the power 8, which is congruent to 8 is an even number, so it's congruent to 35 mod 99. And we can go all the way to CD. So it's CD times 10 to the power of 28. And this is congruent to 28 is an even number, so this is congruent to CD mod 99. And we go all the way again to 95 times 10 to the power of 36, which is congruent to 95 mod 99. And last but not least, our very lonely 2 times 10 to the power of 38 is congruent to 2 mod 99. Well, as we see, we have already dug out our CD. Well, what do we do from now? Well, remember our last video where when we've got to this step, we added all of them on the left-hand side and on the right-hand side. So we're actually going to do that. So the left-hand side, if we add it up, then it'll just be 34 factorial. And this is congruent to you add all of the right-hand side up, which is, if you do this on your own, you'll get 690 plus CD. Mod 99. Well, some of you guys might be wondering, what is the point of this? We've done this much work to get to this little statement. Well, 2 more steps until we can solve it. 34 factorial is congruent to, since this is mod 99, we can take out as many multiples of 99 from this as we want. And if you take as many as you can from there, then I'll just tell you it will be 96 plus CD mod 99. Would you believe me if in one step we could solve our CD? Well, let's recall what factorial means. Factorial means we multiply from 1, 2, all the way to 34, right? But I'm going to write a few more. Times 9, times 10, times 11, all the way to 34. Well, this is mod 99, right? Well, here we have a 9 and an 11. 9 times 11 is 99. And like I said, if 99 is hidden in this number, then it must be divisible by 99, right? And this is the beautiful part. This inside has to be a multiple of 99. But it can only be 99 times 1. Because if it was 99 times 2, which is 198, then CD would be a 3-digit number, which is illegal. So CD is equal to 03, right? So C is equal to 0, and D is equal to 3. A is equal to 2, B is equal to 0, C is equal to 0, and D is equal to 3. Done. Well, thank you guys so much for watching, and if you enjoy my videos and you like number theory content, please consider liking and subscribing. If you want to master something, teach it.